Hello, welcome to this tutorial on interfacing Arduino and processing. So in this section we will see how our Arduino hardware and the processing software can talk to each other. The Arduino can talk to your computer using the USB cable. As we know, the Arduino hardware has an Atmega 168 or 328 AVR processor, which has an serial communication, and then it is interfaced to a serial to USB converter, which we call it as an FTDI chip. So when the microcontroller receives a sensor data or wants to communicate with the PC, so it sends the information as a serial information through those receive and transmit lines, or the transmit and receive lines, to the computer. So the FTDI takes that serial information and converts it into a USB signal, which is again a serial transmission, and it reaches the PC. So processing again can handle these serial communications too, and can take these inputs from the Arduino hardware, and we can then create again powerful, flexible applications in very short time. So this is basically the main concept of using processing and Arduino. So as we can see, when we want to talk to other devices or serial devices in Arduino, so we use serial begin, and when we want to send out information we can use serial.print, and then when we want to read information coming from the PC back to the Arduino hardware, we can use the serial.read function with Arduino. So here's a very simple example. This is actually described in Arduino. So the only thing we have to note here is, as you can see, that we have enabled our serial console by clicking on this particular icon. We can pop open our serial window. So in this case, as you can see, we are trying to initialize. So this is again the blinking of an LED, but we want to send some serial information out of the serial port. So here is an initialization command in the setup which says serial.begin, and it initializes our serial communication port to a particular speed. So we call that as a baud speed. So it is at 19,200 bytes per second. Bits per second. So, and you can see that once that has been initialized, and so there is our blinking of the LED. So every time there is a blink, it also tries to print the string hello world into the transmit pins. So and when you look at this, you will see that not only does the pin number 13 blink on and off, our Arduino board also has LED connected to the transmit and the receive pins. So there is an LED there, and so you can see that it would be flickering or blinking quite rapidly. So similarly, if you want the PC to communicate with Arduino, so in this case we're just using a built-in, as I said, the serial console, which is built into the Arduino IDE, because the Arduino IDE is running off the PC. So if you want the PC to communicate to the Arduino, so here is an example. Again, we are initializing the speed, the baud rate of the serial device, and in your, once you click on this, your lower um, output console becomes a serial output console, and this small window here becomes your input console for the serial, and then you can select your baud rate by using this pull down menu or pull down selector. So here you can see that we are checking if the serial port is available, and then we are trying to read it. When the value is equal to H, then we tend to toggle it, else it just stays off. So by typing the letter H here and pressing the send button, the Arduino hardware will be able to receive this letter. So this is how in this case, the software, which is the Arduino IDE, communicates with the Arduino hardware. So as you can see, this is a block diagram explaining how information flows from your Arduino hardware to the computer. So this is your microcontroller, the Atmega 168 or 328, and you have your FTDI, which is serial to USB converter, comes through the USB. Again, at your in your laptop or your PC, the USB is again converted into serial information, and either you're going to use your Arduino IDE, that's what we saw. You can use processing, you can use Java, or you can use many other forms of framework to actually decode this serial information. So again, whenever we want to send data from the Arduino to the PC, we need to, or the PC to the Arduino, we need to initialize, or we need to make sure that we are sending it in the right format. So as we can see, we have seen the serial.print of a value, so that is actually transmitted as an ASCII value. But if you want to be specific, you can also say transmit as a decimal or a hex or a binary value or a byte. So it also gives you all these options of how specifically you want to send this information. Okay, so here we come to the most important part in the interface. This particular snippet of code explains how the Arduino is actually talking to the processing IDE. So the Arduino hardware, whenever we implement the sketch, you can see in the loop, we try to read it from an analog input using an analog read signal, and then we divide that by 4, place it onto the serial.print, and therefore the Arduino sends this to the PC. On the PC side, as you can see in processing, we open processing, we import the library for reading from serial port. So we defined our instance of serial port, which is my port. We also have to specify the exact port name. So this is a typical port name description in Mac. So if you're doing Windows, it'll be like COM1, COM2, COM3, whatever. And we then define what is the baud rate. So it's now, as you can see, it's 9600 is the baud rate. Now here you can see if the port is available. So in other words, if it is enabled and it's working, so it is going to go read it from the port. That is, this value which is being sent is going to be read by this, and it's going to just simply get printed. So if you want to now plot it, you can plot it. If you want to now do more modifications with the obtained data, you can go and do it. So this is a very simple setup where the Arduino here is trying to send the information to the serial port, and processing here is trying to receive that same information and trying to process it. So again, processing is not the only interface or the software that you can use with Arduino. There are various other languages and IDEs which have been used. Common ones are C, C++, Perl, PHP, Java, Max/MSP, Python, Visual Basic, C Sharp, etc. So a lot of these frameworks have been used to actually interface with your Arduino hardware. Alright, so as we've seen earlier, as far as the processing is concerned, we will need to use the serial library. We need to make sure that you have an instance of port which is open. You need to give it a name and then the baud rate in which it's actually expecting it to receive. And then you can open the port, write to a port, check if a port is available or not. or you can also say in case of a serial event, which means whenever there is a write operation or a read operation, etc., that forms a serial event, what you would like to do. So as you can see here again, when you process it, for this case in a Mac, we have to specify the right serial port. If you're using Windows, then you have to come up with the correct COM port to which the Arduino hardware is connected. So in this case, this is where the Arduino hardware is connected to this case. In Windows, this would be the port to which the Arduino hardware is connected. So we can now change most of our experiments which we did in Arduino by simply adding a few lines of code and processing. So here you can see that we have used a lot of applications where we have used a potentiometer to control the analog value which is going into the Arduino. But if you want to actually see what is the analog value which is read by the Arduino, so you can actually implement a serial port or a serial instance in your Arduino. So this is you change the code here to transmit or enable the serial and transmit your value as a byte on from the Arduino. And in processing, you can just simply display it, or you can again use just Arduino IDE to simply display the analog value obtained. So if you're trying to do something more creative, then this is another application where you can see that the part value from your hardware is now controlling an Arduino. um, it's actually controlling the color of this particular circle in processing. So as we see, the setup is the same. So here you can see that's the port in which the Arduino is connected. So we have initialized our port to 19,200 bits per second. So and then whenever the port is available, we try to read it, and depending on that value, this hue factor or this particular color is changed. Again, another example is again same using the part, but in this case the processing simply implements a bouncing ball. But as you increase the part value, what happens is the size of the ball gets bigger and bigger. So that's another application. Again, just read the value from the part, send it serially out of the Arduino hardware, processing gets it, processing determines, gets the value, and then uses that as a part of your value of R in your eclipse to change the size of the circle or the eclipse. Here again we have a randomly moving ball, and the part again is used to determine the position of this pong. As you can see, it can be by changing the value in the parts, so you can actually make the slider to move from anywhere from this point to this point. So and then the idea of the game is to make sure that the ball is not is reflected off the pong and doesn't go into outside the scope of the box. So these are very simple applications which can be simply created by just reading in the values of your potentiometer from the Arduino hardware. So here is another application. As you can see, we are now will be controlling the light or the color intensity of an RGB LED. The RGB LED contains three different inputs. They have inputs for R with the red component, G for the green component, and B for the blue component. And as you can see here, we are using the advantages of using processing is because we are trying to read it from a URL string. That is, this contains a color text of three different color components, and once it reads the text, it passes through it, takes the color it wants to display, and then feeds it back into the Arduino. And when the Arduino gets this value through the serial port, it is going to set the PWM values, or pulse width modulated values, of each component, which is the red component, green component, blue component, and thereby producing different colors. So this is an application where you have a file on the internet which specifies a particular color or a sequence of colors. It can read those colors and then display it in the Arduino hardware. So in other words, the Arduino hardware can be in your office room or in your bedroom or any place or any location, but still the control is done by a simple text file loaded onto a web server or onto a remote system. So the code for that particular application on the processing side is only a few lines. So therefore it is easy to imagine that the power of processing and the flexibility and easiness to control hardware, Arduino hardware.